7 Curious Theories About Time Travel.
Time, something that is hard to understand, but which nevertheless defines the finitude of our existence and the essence of our own mortality. It pushes endlessly and inexorably forward without ever looking back.
Or does it? The idea of visiting the future or traveling back in time is something that has plagued our imagination since the beginning of time, and which touches the border of science, fiction, and philosophy. In today's video, we'll explore 7 curious, albeit very real physical theories about whether time travel is truly possible or not, and about the possible outcomes it entails. Your head will be spinning before the end, and you'll know what Hollywood got right or not. But before we jump into time travel, please support our channel by subscribing, and don't forget to hit the bell icon for more videos. Is time travel really possible? In short, yes, but only forward, not backwards. Traveling to the future is a piece of cake, but traveling to the past is a whole other matter. Let's see how that works by going over some of the most prominent theories about time. Theory number 7, Einstein's time dilation theory. Traveling to the future is so easy that we do it every day. You see, according to Einstein's theory of relativity, time is, well, relative, hence the theory's name. It is relative to the observer's motion and to gravity. What that really means is that time goes by differently for two objects or people depending on differences in gravity and on the relative speed in which they move with respect to one another. This effect is called time dilation, and even though the math is very complex, the idea is very simple. The higher the gravitational field we're in and the faster we travel compared to others, the slower our time goes by. The only problem is that for time dilation to be perceivable, we need to move very fast, like nearly to the speed of light fast. However, we can still measure it easily enough with a sufficiently precise clock. An astronaut in the International Space Station travels at almost 28,000 kilometers per hour, or roughly 0.003% of the speed of light. After a couple of months traveling that fast, their watch would show a time that is a couple of milliseconds behind ours here on Earth. A small difference, but measurable nonetheless. If we traveled at 99.999% of the speed of light, our time would go 223 times slower than everyone else's. As a consequence, if we traveled for 1 month at that speed and came back home, 18.5 years would have elapsed on Earth, so we would have effectively traveled to the future. Theory number 6, traveling to the future on a black hole. We still haven't built a rocket that can propel us to any significant fraction of the speed of light. But perhaps we can slow time and travel to the future in other ways. Black holes are very strange cosmic things. They're so massive and their gravity is so strong that even light gets trapped inside them. We won't survive a trip to a black hole's center, but perhaps if we manage to orbit one at a distance close enough to feel its immense gravity for a while and do a slingshot back to Earth, we could travel to the future without the need to go lightning fast, or light fast, really. Even though going to a nearby black hole or traveling at the speed of light are nowhere near our scientific and technological horizons, at least these options are feasible and have been proven to really work. We know that traveling to the future is possible, but there's a big problem with traveling back in time. Keep watching to find out what that problem is, and if and how it could theoretically be overcome. Traveling to the past and the Grandpa Paradox. We all love sci-fi movies where time travelers go back in time and change the course of history. But when you stop to think about it, it really doesn't make any sense at all. And the reason is something called the Grandfather Paradox, which works like this. Suppose Marty McFly took the DeLorean for a spin, accidentally ran over his grandfather in the past, and killed him before he had kids. That would mean that Marty couldn't have been born in the first place. But if he wasn't born, then he couldn't have gone back in time to kill his grandfather. Therefore, his grandfather would have lived to have children, and so Marty would have been born and could have gone back to kill him. You can see how the paradox unfolds, and this alone makes it logically impossible to travel back in time. But why are we talking about different theories about time travel then? What's the point of traveling to the future if we can't come back and brag about it? We'll get there in a minute, but keep watching to see how some theorists have worked around the paradox and Einstein's theory. Theory number 5, the quantum theory of parallel universes. There are two basic ways to go back in time without creating a paradox. One is based on the Novikov self-consistency principle, which simply states that the probability of anything happening that would change the future leading to a paradox is 0. So even if we did go back in time and try to kill our parents, we wouldn't be able to. We'd have to be something like Ebenezer Scrooge in A Christmas Carol, flying around the past like ghosts without being able to interact with anything or anyone. It would still be really cool, something like an immersive VR experience. The second way out of paradoxes makes a bit more sense in a very confusing and seemingly senseless way. It's the multiverse or infinite splitting universe theory that is predicted by quantum mechanics. To make a long story short, it basically states that there exists an infinite number of parallel universes at any given moment. Since every conceivable outcome of traveling back in time is possible in at least one of these separate parallel universes, all the time travel paradoxes lose meaning. What this really means is that if we were to go back in time, we would end up in a different parallel universe to our own. Everyone there would look exactly the same, and we could walk up to our least favorite grandpa and tip him off a cliff without fading out of our photographs. You see, even though Gramps may look exactly the same, he wouldn't be the same one that led to your birth. He wouldn't be your grandpa, just some parallel clone. Our real grandfather lives in the other universe we left behind, which we'll never set foot on again, by the way. Not a promising thought. Theory number 4, Tipler's cylinder theory. The only way to travel back in time is to bend or warp space-time into something called a closed time-like curve, or CTC, wherein by traveling forward, you would eventually cross into the past. Tipler's cylinder is a machine that seeks to accomplish this without the need for speed faster than light. It consists of a long and very thin rod with the mass of 10 suns squeezed into the thickness of a human hair that spins on its axis at a few billion RPMs. Tipler proved that such a construction would warp space-time around it, generating a CTC along a carefully described spiral near the axis, which we could travel on a spaceship. The problem is that for this to work, the cylinder would need to be infinitely long, which is unrealistic at best, but at least it's a possibility that doesn't mean certain death for the spaceship's crew, like other options coming up on our list. Theory number 3, the donut vacuum. In 2005, Amos Ori from the Israeli Institute of Technology published a theoretical design of a time machine that could hypothetically achieve a closed time-like curve without being infinite in size. His theory states that if we were able to bend gravitational fields into the shape of a donut with a vacuum inside, we would create a space-time loop that would contain all the time periods after the donut's creation. Therefore, we could travel back and forth between any two times by going from point A to point B inside the vacuum. The cool thing about this wild theory is that the donut is much more stable than wormholes and doesn't need any inexistent exotic matter to work. But then again, you can't really go back to before when the donut was created, so no dinosaur pics on your iPhone. Theory number 2, cosmic strings. Cosmic strings are a set thin and massive heavenly bodies that can warp space-time around them enough to allow time travel. These are narrow tubes of energy left over from the Big Bang, something like long cracks across the universe. In theory, if two of these strings were to come close enough in a specific configuration or shape, they could generate the closed time-like curve we mentioned earlier, and by traveling through that curve, we could theoretically travel back in time. The neat thing about this theory is that if those cracks were created when the universe was born, and if by chance two strings formed the CTA billions of years ago, then we could, in principle, travel to any past we could possibly want. In other words, we could ride dinosaurs. This one's for you, Johnny boy. Theory number 1, Alice through the transversible wormhole. There's a theory that states that wormholes could be shortcuts to the past and future. They're like gateways that have an entrance and an exit, with either located in a different part of space-time. According to this theory, to make a time machine, we would first need to create a wormhole, then take one entrance, imagine one of the doors at Monsters Inc. or Harry Potter's Vanishing Cabinet, and accelerate it close to the speed of light, or take it near a very massive object, so that its time slows down for it while the other entrance ages normally. Once we bring the first entrance back, we'll have a tunnel between two different times. So let's say that we accelerated the first entrance to 99.984% the speed of light for 5 years, so it is now in the year 2025. For the stationary entrance, it'll be year 2300. So if someone were to enter the stationary entrance, which is in the year of 2300, they would exit through the accelerated entrance, which is in the year 2025, effectively traveling to the past and vice versa. However, there are several caveats with this time machine. First, we don't really know if wormholes exist, and we haven't got a clue as to how to make one. Second, as far as we know, only very small particles can travel through wormholes before they collapse, so we won't be able to go ourselves. Third, for a wormhole not to collapse into itself due to its immense gravity, it would need some sort of strange and exotic anti-gravity matter to support it, which simply doesn't exist. Finally, if you're witty enough, you may have spotted the very important fact that when it's traveling back in time, we can only exit at the accelerated entrance's time, currently 2025, so it's impossible to go back any further than when the wormhole was initially created. Sorry, Johnny boy, no dinosaur riding for you. Can you guess which of these theories have already been used in Hollywood sci-fi flicks? Of all these seemingly wacky theories, which one do you think is more interesting? And if one of them could eventually work, where and when would you like to go? Would you go back to tell yourself to ditch your cheating fiance, or would you buy shares in Apple, Google, Facebook, and Amazon? Let your imagination run wild in the comments section below. It'll be great to see what you all have to say. Also, if you liked this video, don't forget to like, subscribe to our channel, and hit the bell icon for more like it. Thanks for watching.